To understand the true complexity of industrial safety, look at the scale of a modern processing facility. We are managing millions of square feet, miles of piping, and hazardous materials present at nearly every turn. Zoom in on just one element, a single 55-gallon drum of an industrial solvent sitting on a receiving dock. That single drum is governed by specific legal liabilities, but which federal agency holds legal jurisdiction over it right now? If it's rolling off a truck, the Department of Transportation dictates exactly how it must be handled, labeled, and moved. But the moment a worker opens that drum to use the solvent on the factory floor, the Occupational Safety and Health Administration takes over to monitor human exposure. And when that solvent is spent and poured into a disposal container, the Environmental Protection Agency steps in to govern its path into the waste stream. These jurisdictions do not exist in separate silos. They overlap, creating a regulatory intersection that facility managers must navigate daily. The ASP and CSP exams frequently present scenarios where these jurisdictions collide in a single paragraph. Identifying exactly which regulatory phase applies is the primary point of friction for most candidates. We can manage this by mapping a chemical's journey using a regulatory lifecycle matrix, tracking the material from the receiving dock through the factory floor and into the waste stream. A material's exact physical state and its physical location in the facility define how it must be managed under the law. Move a chemical 50 feet from a storage rack to an active workstation, and the mandatory storage controls shift to an entirely different set of codes. Similarly, emergency response liabilities trigger under different federal statutes depending on whether a spill happens during a transfer or from a waste bin. The BCSP requires candidates to master the specific numerical thresholds that trigger these various classifications. By deconstructing a facility into these chronological phases, a complex situational prompt resolves into a specific jurisdictional requirement. We begin in Phase 1. The material arrives at the facility, placing it under the jurisdiction of the Department of Transportation. This matrix shows the DOT Table 27.2 hazard classes. These classifications dictate transport rules before a material ever enters a facility's active process. Let's focus on DOT Class 3 liquids. The DOT sets a strict thermal threshold. If the liquid has a flash point of 141 degrees Fahrenheit or less, it is classified as a flammable liquid. If that flash point rises above 141 but stays below 200 degrees, the classification changes to a combustible liquid. Other classes deal with highly volatile reactivity, like DOT Class 4.2. This class specifically covers solid substances that are liable to spontaneous combustion without an external ignition source. Then we have DOT Class 4.3. This covers materials that are dangerous when wet, meaning they emit flammable gases upon contact with water. Anchoring a physical property, like a 141-degree flashpoint, directly to its DOT hazard class prevents the misapplication of OSHA storage rules to a transport scenario. In Phase 2, the chemical leaves the loading dock and enters active factory use. The moment that drum is opened, OSHA jurisdiction begins. OSHA's regulatory focus is mitigating a worker's direct occupational exposure to the hazardous material. Under OSHA's Hazard Communication Standard, this phase requires mandatory labeling and the availability of safety data sheets for the workers handling the substance. OSHA also governs the specific personal protective equipment required to safely perform active handling. Here, permissible exposure limits, PELs, become the mathematical threshold that determines legal compliance. Active use is an OSHA-type problem because the primary risk matrix is human occupational health rather than public environmental impact. Phase 3 begins when the chemical is spent and officially becomes a waste product. This triggers Environmental Protection Agency jurisdiction. Routine waste management falls under the Resource Conservation and Recovery Act, or RCRA. Facility compliance is now determined by the exact volume of waste generated per month. EPA Table 27.1 breaks generators down into 3 tiers: conditionally exempt, small quantity, and large quantity. Large quantity generators produce the highest volume, restricted by a 90-day limit. Small quantity generators have a lower volume, allowing a 180-day limit. Exceeding these accumulation time limits without a treatment, storage, and disposal permit results in federal violations. Routine waste management follows a predictable, volume-based timeline. On the exam, you must distinguish this controlled process from emergency response scenarios. Phase 4 occurs when primary and secondary containment fails, leading to an uncontrolled spill. This release shifts the regulatory framework away from routine RCRA management. This scenario falls under the Comprehensive Environmental Response, Compensation, and Liability Act, widely known as Superfund or CERCLA. CERCLA is funded through specific taxation on the chemical and petroleum industries. It provides federal authority to respond directly to environmental threats. Under CERCLA, federal authority is not limited to actual spills. It extends to the threat of a release of hazardous substances. The Act establishes strict retrospective liability for any endangerment of public health or the environment. A spill is a CERCLA-type problem because it has escalated past a facility compliance issue into a public environmental emergency. Consider a typical situational exam question. A facility generating hazardous waste subsequently experiences a large-scale spill. We map this scenario against the life cycle, starting with DOT transport, moving to OSHA active use, EPA RCRA accumulation, and finally EPA CERCLA release. The question asks, which regulation dictates the immediate federal response authority for the spill? By identifying the exact phase, an uncontrolled release, we can eliminate transport, workplace exposure, and routine waste rules, leaving CERCLA as the correct answer pathway. Read the stem of the question meticulously to identify the material's physical state and its current location in the life cycle.